In Unit 2, what we will be seeing is how to initiate the SQA activities in the organization. We look in detail in what goes into the SQA plan, because they say well begun is half done. So the SQA planning has to be given due importance to ensure that all the activities during the project life cycle are executed as per the SQA plan. We will also look at some of the tools that we can use for doing causal analysis. This is jumping at the gun a little bit because we have not really introduced metrics, but these are tools that you can do causal analysis for without really having any quantitative data as well. It could be used for qualitative data. And we'll also look at the process improvement life cycle, which we said we would do subsequently when we were doing Unit 1. So in Unit 1, we saw the difference between quality assurance, quality control. Simply, quality assurance is preventive activities. Quality control is detecting and correcting the defects. So anything that's done before the coding phase are quality assurance activities, and what's done after are quality control, because after that you've already introduced the defects in the code and you have to correct them. We also looked at cost of quality, where we said there are three components. One is the cost of prevention, which costs associated with identifying the causes of the defects and taking actions to prevent them in future. There's cost of appraisal, which is the cost of evaluating the work products to determine its quality level, and the cost of failure, which is the cost of diagnosing the failure. That means making necessary repairs and getting the software back into operation. We also saw the QMS, the development, the creation and the maintenance of the QMS, where first we need to identify the processes that are needed for the QMS and also determine their application throughout the different projects that are being executed in the organization. We then determine its sequence and the interaction of these processes, how one process interacts with the other. This information is needed when you decide to change a process, so that you know how changing one process may impact another process. Then we saw to determine the criteria and methods needed to ensure that the operation and the control of the processes are effective. We also talked about ensuring adequate availability of resources and information necessary to support the operation and monitoring of the processes. So there should be the people with the right skills allocated to the projects. We talked about monitoring, measuring and analyzing these processes, and we'll see a little more about this aspect in this unit. And finally, implementing action necessary to achieve the planned results and also ensuring continuous improvement of the processes. The goals of SQA, we already discussed this. Three primary goals: improving the software quality or facilitating the improvement of software quality. The SQA themselves cannot do anything much about quality. Ensuring compliance to standards. So anything that's defined, written in the QMS, which is of course aligned to any business model or any quality model that you want to adhere to. And finally, highlighting issues, if any, to the management for corrective action. So facilitating the improvement of software quality, ensuring compliance to standards and highlighting issues to senior management. Remember that SQA by themselves cannot do anything about quality. They are only there to check for adherence to the process and highlight any process issues. The existence of an SQA does not ensure that standards and procedures are followed. So it doesn't mean, the SQA is anyhow doing a sampling, may not do 100% review of everything. So their presence really does not 100% guarantee that all processes are being followed. The SQA will never be effective unless there is visible support from the top management. When we say visible support, means people should be able to see that the management is taking action on the reports submitted by the SQA, that they are stopping deliveries with quality issues, with those deliveries where SQA have highlighted issues. Remember that it is possible that in spite of SQA highlighting issues with a product, with a delivery, the management still goes ahead. Okay, these could be some exceptions because of some informed decision that they are taking, okay, that some phase-wise rollout has to happen, or they have already spoken to the client. Sometimes the project team themselves makes a delivery with a list of known issues in the software. They have to make the delivery that day, so they have to adhere to the deadlines. But since they know, they also tell the client that, look, these issues still exist and we are in the process of solving them or resolving them, and by so and so date we will resolve them. That also happens once you have a mature and educated customer. It's basically SQA is just highlighting the deviations from the defined processes and alerting the management on what problems need to be fixed. For a successful SQA program, there has to be an appropriate development methodology defined. It could use any of the life cycle models. It could use the waterfall model, the spiral model, the rapid application development model. It could use any life cycle model, but there has to be a defined application development methodology. Defined standards and procedures need to be used by the project team. Effective SQA program, there will be independent reviews of the product and processes by the SQA. Mostly processes to see that adhere to the defined standards, and products on a sample basis to see either complete or on a sample basis to check their completeness and correctness. There will be production of documents during the activity, not after. So it's not that, okay, now the SQA review is going to happen or the audit is going to happen and I now fill in all my review reports and project plans. While I'm doing the review report has to be filled. When I'm planning for the project plan has to be prepared. When I'm doing the requirement analysis, the software requirement specification document has to be prepared. At the end of each phase, I will update the traceability matrix. Not that at the end of the project or after testing I will update. So every activity or every documentation that has to happen when that particular activity is being executed, not after that has happened. You may forget and you may not record all the information which is necessary. For an effective SQA program, we also need to ensure that there is an effective change control mechanism. And we will talk about change control in detail when we talk about configuration management, but there has to be proper change control process or mechanism. There has to be emphasis on testing on all high risk areas. So testing is not a negotiable activity. It has to be done and as per the test cases, as per the test plans. Since we have defined the sequence of activities in the QMS, then this means that tasks have to be successfully completed before going to the next. And this will be done through phase inspections. So after every phase, there will be a review to see that all the tasks of that phase have been completed before going to the next phase. If there are any deviations from the defined process, and there should be proper review and approval of those deviations. These deviations would probably come if it's suddenly a new type of project has come along. So you've been doing long projects all along and suddenly there's a short project of 2 weeks. So you need to do a little bit of tailoring, of course, but those tailoring guidelines don't exist in the QMS because this is the first project of its kind. The QMS has to be developed and maintained as per the defined processes of the QMS, and we will look a little bit on how we update the QMS processes a little later in this session. And of course, then quality management itself has to be done as per the defined procedures. Reiterating the functions of the SQA, something we have done in part in Unit 1, is that the tools, techniques, the methods and standards all have to be defined and available for use. So it has to be easily available either in a repository or in some form. It has to be available, and themselves have to be periodically reviewed to determine its adequacy, to determine its currency, whether it's applicable for the current projects or not. The project planning phase is reviewed by the SQA. The project plan is, as I mentioned earlier, Bible for the SQA. So based on that, all the other SQA activities will take place. Therefore, completeness of the SQA plan, which includes the SQA plan, configuration management plan, risk plan, communication plan, etc. The whole project plan has to be reviewed by the SQA. Requirements review is also done by the SQA. high quality requirements are necessary for high quality products. Therefore, the key is reviewing the requirements to ensure conformance for established standards, that they are complete, that there are no inconsistencies, that they are easy to understand. So, requirements need to be evaluated, need to be reviewed. Evaluation of the design process is also a function of the SQA, where the quality of the design review itself is evaluated. So, the design document has been prepared by the designer and a review has happened. What is the quality of that review? Was that done effectively? Were enough issues identified? Was again the document complete? Was it in sync with the requirements document? Was the traceability matrix updated? All that is checked during the evaluation of the design process. During the evaluation of the coding process, the SQA looks at the adherence to the coding standards, whether they have been adhered to, whether appropriate documentation has been maintained, whether variable names are meaningful names, whether there is adequate documentation to maintain the software. All this is defined first of all in the coding standards and then evaluated while the coding process is being reviewed by the SQA. The SQA also evaluates the testing process, whether there is an independent group doing the testing, whether the test plans have been prepared early in the life cycle of the project. Ideally, the test plans should be developed during the requirement phase itself, because you know the requirements. So, defining or listing the test cases should not be an issue. The practice of writing the test cases by the programmer or by the developer after he has developed the program is not at all recommended, because if I am the developer and I have developed a code, I will develop test cases which are aligned to that test code. It is a human tendency to do that, and that's not what we want. We want the test cases to be developed based on the requirements of the system. Again, the quality of testing, whether adequate number of test cases have been considered, whether the test results have been properly recorded, all that will be reviewed by the SQA. Also, in-process evaluation of the management and project control processes to be done by the SQA. This ensures that the focus of the entire organization is on producing quality results. And finally, tailoring of the processes, which should be as per the needs of the customer, as per the specific project requirements, individual project requirements. So, what are the basic steps when we launch an SQA function? So, launching an SQA function involves various steps. First is, of course, initiating the whole program. Just like you have a project kickoff meeting, you kick off the SQA program. Then you identify any issues that you may have. So, will you have adequate people to staff the function? Will people take kindly to it? How will you train people in the SQA function, in the benefits of the SQA function? Will the client accept this additional cost to quality, or will the organization absorb this cost to quality? So, all issues relating to the SQA function need to be identified and resolved. Then we need to actually write a plan, right, the SQA plan at the organization level, based on which all the activities will be executed. Training has to be conducted both for the SQA personnel as well as the others, for them to understand the benefit of the SQA function, for them to understand what value will the SQA function add to their project. Finally, actually establishing it, starting their operations, implementing the activities as per the SQA plan, and finally monitoring this SQA program. Are the SQA activities themselves effective? Do we need to change anything? What are the measures in the plan itself? We will define certain metrics or measures to determine the effectiveness of the SQA program. And are we reaching that goal? Are we on the process or on the path to reach that goal, or are we very far from that goal to achieve the SQA targets? So, the SQA process itself has to be monitored, has to be evaluated, reviewed for its effectiveness in the organization. Very, very important prerequisite, without which nothing in the SQA department can be of success, is the senior management commitment. As I have mentioned before, there has to be visible demonstration of support to the SQA function. Quality has to be treated as a strategic business issue, because if you have quality products, then you can demand a premium price for your product, your market share will increase, your profits will increase. There will be more business coming in because your reputation will spread in the marketplace, your organization will attract good people, and because you are generating more revenues, you will be able to give them higher salaries. So it's all a vicious circle which will happen if quality is in place. So it is a strategic business issue and has to be treated as one. The quality policy has to be developed, a policy that can be implemented. A lot of people have policies which are just words. Creating of the quality policy was the first clause that the ISO model dictated. So most organizations, software and otherwise, have a quality policy. But this policy should reflect the culture of the organization, vision of the organization, what the organization stands for, and it has to be a quality policy that can be implemented in the organization, just not words, that we want to be the best software producer in the world. I mean, sometimes I don't even know what that means. Senior managers have to make an effort to educate the customer. Okay, a lot of customers sometimes don't understand why so much time is being expended in various quality activities, why the cost of quality is increasing. Sometimes we may not even pass on the cost to the customer. We may be absorbing the cost ourselves, but additional time will be required, additional effort will be required for the SQA activities, and the client or the customer, if they don't understand what's happening, may be wondering why so much time is being taken. So they have to be educated, they have to be taken into confidence that this is our process, these are the results of our process, and if we follow these processes, then it is the customer who's actually going to benefit in the long run. The senior management also has to ensure that the quality policy is communicated to everybody in the organization, and more importantly, that it is understood by everybody in the organization. More importantly, is something that everybody uses or everybody implements in the organization. It's not enough to know and understand, but you have to live that policy as well. And senior management has to ensure that happens. Finally, this quality policy itself has to be reviewed periodically, and its implementation also has to be reviewed periodically to see that people are indeed following the policy, to see that the policy indeed is applicable to the organization even after 3 years, even after 5 years or 10 years, and that people truly believe in that policy and are living that policy in their day-to-day activities. SQA planning, a very important aspect of the SQA function, because quality is achieved only by building it into the software process. It is achieved by doing this throughout the life cycle of the project. We cannot just say that we start the project with quality and end it with quality. It has to be an ongoing intervention or an ongoing interface with the project throughout its life cycle. So the quality of the software must be continuously evaluated. So each and every work product which goes into creating the software, the code, has to be reviewed and assessed continuously. And this evaluation should be planned and documented for, so that everybody in the project team knows that these are the quality assurance activities that will happen, and they will happen at these intervals of times. It will take so much time, and we will get so much time to take action on the review reports. So the SQA plan has to be done early in the life cycle, in the first phase of the project, where the project plan is being created. This plan may or may not be a separate plan. It could be a plan which is part of the project plan, or it could also be a independent plan. That is up to the organization's QMS, how it's defined. What are the contents of an SQA plan? First and foremost, you define the purpose of the plan. What is the scope of the software products that you are going to review as part of the SQA activities? Secondly, you will list the different reference documents that are being used for the SQA plan. What are the documents you are referencing to come up with this plan? The third category is the management category, and this is the huge chunk of the SQA plan, where first you will define the organization of the project, the SQA organization in the project. What are the different roles and responsibilities of the SQA, and what is the hierarchy, what are the reporting relationships in the project. Secondly, you will define the chronological sequence of tasks in which the SQA will participate. So it starts with the plan, the project plan, the kind of configuration management plan, the SQA plan, all these, if they are separate, or only the project plan, if they all are bundled together as SQA, you may not be able to comment on the content of the SRS, but definitely how it has been reviewed and whether it's complete or not, whether the template has been used or not. Similarly for design, review of the design process, review of the test planning process, review of the coding process, review of the actual testing and all the testing, the unit testing, integration testing, system testing, all sorts of testing, all how are they being executed, are they being done as per plan. Will the SQA take a sample of the test cases and see whether the test cases are valid, are going through. All this has to be mentioned in the SQA plan. The SQA plan will also define the review of the documentation of the user manuals, the training manuals, of any other documents that are going to be used in the project. The responsibilities of the SQA are defined, and there is an agreement on the quality plan between the project team and the SQA. If there are any disagreements, then these need to be resolved before this plan can be executed. Any corrective action, so after the SQA has done its review and the corrective action has to be taken place, how that is to be taken place, what is the time frame within which that corrective action has to take place, has also to be agreed on with the project team or with the project manager. What are different project activities that are going to be reviewed, that has to be mentioned, including audits. In your textbook, audits are mentioned as part of the SQA function. As I mentioned, that there could be a separate group doing that, or there could be an overlap. So just be careful about that distinction. In the audit function is different from the SQA function, and if one person is doing both, though there is a conflict of interest, sometimes if it's a small organization and there are no resources to do that, it could happen, and you have to wear a totally different hat when you are an SQA person, when you are a friend of the project, and when you are a third party auditor of the project. What authority the SQA has, what are the powers that the SQA has? Does the SQA have the power to stop a delivery, or they can only highlight the issues? That has to be mentioned in the SQA plan. And what sort of expertise is required, any training, additional training that the SQA people need, or any additional training that the SQA has to give the project team, has to be mentioned in the project plan. Any documentation review, of course, I already mentioned. Also standards, practices, templates, reporting formats, all this needs to be reviewed. So basically the entire gamut of documents that are produced by the project has to be reviewed by the SQA. Now what does the SQA review actually? Suppose it is the SRS review. SQA will review for adequacy, they will review for conformance to standards, they will ensure that those requirements form the basis from which the software of the desired quality can be developed. They will review for internal inconsistencies, if any, whether all the requirements are understandable. This document will go to the design document for development of design. So will they be able to understand this document and develop the design document? Is it complete? Is it easy to understand? All this has to be reviewed by the SQA. During the SRS review, it is also important for the SQA to review that the required quality aspects of the product are specified in the specs. Proper analysis has been done of quality to determine the adequacy of the requirements. And finally, that every requirement has a unique identifier so that traceability can be established. In the preliminary design review, that is in the higher level design review, again the SQA will review to see that the design has been developed as per the defined methodology. And again, all the tasks that have to be done during the design process, say a pilot to be done or joint application development to be done, all those have been done. And finally, of course, that this design is the right base, it forms the basis for all future activities, the lower level design, the coding and the testing. The SQA will also determine or will also evaluate the design to see that this design when implemented does not clash with the sizing constraints of the hardware, that there's adequate memory available to implement that design. Standards, of course, so conformance to standards, internal consistency, understandability again, because the coders have to understand the design, completeness and the right amount of detail so that it may be translated into the code. Again, during design phase, traceability has to be checked for, and at this time the bidirectional traceability takes importance as well. So not only whether the requirements have been translated into design, that every design aspect that has been listed has a corresponding requirement defined in the SRS. In the critical design review, that's the lower level design review, again the first thing to check for is that it is in accordance with the standards that are defined and it is technically feasible to implement. All the components are there. There's an application architecture, the ER diagrams if they have to be there, the state transition diagrams, the concepts of coupling, cohesion, and I will talk a little bit about that at the end of this session. Internal consistency will be a common factor, that again it's understandable and complete details again. So in design it's very important that all the details are available because that's the last stage before the coding begins. Traceability again will be checked for. By this phase, all the test cases have to be prepared. It's advisable not to go into coding without the test cases or the test plans in place. So for the lower level design, the SQA has to ensure that it is in accordance with requirements as set by the SRS or the software requirement specification. They are adequate and complete for development of the test plans and the code, that the test plans themselves have been developed. They can even take a sample design to verify consistency and compatibility with the high level design and the requirements document. The SQA plan also has to incorporate management reviews. So SQA has to participate in the phase end reviews, in the project end reviews. Also when any exception reporting has happened, they have to participate in the management reviews, as I mentioned, be a silent spectator during the review and highlight any issues. Unless they are very pressing and the SQA is very sure of an issue, then they can highlight during the management review, else later with the project manager it can be discussed. Also during the management review, the SQA will facilitate and will assist in the causal analysis of issues, if any. The SQA plan should also mention the configuration management activities, the identification of the configurable items, configuration control, configuration status accounting, configuration auditing. All these terms again we will do in detail when we do configuration management, but this has to be part of the SQA plan. There has to be a reference of that in the SQA plan, especially if there is a separate configuration management plan. The SQA plan also has to describe the mechanism to report a problem and do causal analysis of that problem, how the problems are going to be resolved, how they are going to be documented, how they are going to be tracked, what sort of causal analysis will be done, what sort of classification, is it going to be by category, by severity level, what trend analysis will be done, and basically complete evaluation of the causal analysis and the corrective action process. The plan will also mention what tools, techniques, methodologies are being used and for what purpose they are being used and how they are going to be used, the different tools, techniques and methodologies. The plan will talk about code control, that there should be how unauthorized use will be prevented or how unauthorized modification will be controlled, how the correct version for tracking will be developed. Of course, if there is a tool to do all this, then this section has very less importance. And as I'm speaking, I hope you're realizing that some parts of this will also be part of the project plan. So if there are sections in the project plan that are addressing all these things that the SQA has to review, they need not be again repeated. They could be referenced in the project plan. The SQA plan will also talk about the media control and backup procedures, so protection from unauthorized access or damaged storage requirements to protect the media from any harmful environment conditions, either fire, water, any energy variation, pollution, viruses, etc. Usually one copy of the software is maintained in a remote off-site location to ensure that there is something available in case something happens to the original office or original project location. Disaster recovery plan is prepared so that you know how you plan, restore the software for operation. A lot of organizations do periodic backups, but what happens sometimes when it fails and they try to restore the backup, it doesn't happen. So periodic restorations also should happen irrespective of whether you need or not, because then you know that the backup you have taken is going to help you in the recovery plan as well. The SQA plan also talks about supplier control, and we will be doing a little bit about the supplier evaluation process. So the quality assurance activities have to be aligned to the quality assurance activities of the supplier. The testing, the handing over of the software, either the part of the software or the entire software. And there could be a problem in this if the supplier is, you know, in a dominant condition and they say, no, we won't do what you want us to do. You just have to take it from us the way we give it. So there could be issues in that, and if required, then the parent organization has to take some corrective action on that issue. The SQA plan will also talk about the collection of records and retention of the records, maintaining it, because most projects will go into the maintenance phase. So how you will use, first of all, what are the documentation that will be retained and how will they be used for the maintenance phase. If there is no maintenance phase following the development phase, then what is the interval or what is the duration for which these records have to be retained, and if they have to be purged, based on what conditions they should be purged, all this will form part of the plan. This documentation, record collection, etc. is addressed in the current version of ISO is ISO 9001:2000, and clauses 4.2.3 and 4.2.4 address these issues. I talked about quality policy being one of the first requirements of ISO. That is, I think, clause 5.3 of ISO 9001:2000. Right, so this was the involvement of the SQA in the project activities. So in the project plan or in the SQA plan of the project, all these activities have to be planned for, have to be explicitly mentioned so that they are then implemented as per that plan. At the organization level also, there are initiatives in which the SQA participates. Again, be careful, I talked about the SEPG function. So some of the functions could be hived off to the SEPG group if there is a separate group like that, or it could be a part of the responsibilities of the SQA function. So at the organization level, of course, that the process definitions are standardized has to be ensured. There should be the life cycle models defined, the methods, the tools, what are the tailoring guidelines. So if I can, which processes can be tailored and under what circumstances, what are the risks of tailoring those, and what can I do to mitigate those risks. There should also be guidelines for writing the process documents, for releasing these process documents, and retiring the old versions. Actually, this concept of release notices and retiring old documents is reminiscent of the older system where everything was in hard copies. Now most documentation is kept in soft copies in organization repository, and in all probability a version control tool is used. So only the current version of the process documents is available to everybody in the organization. The other documents are not even available as per the permissions of the tool. So there should be also guidelines for the process document reviews and changes to be done to the process document. Then there's process management, which is a responsibility at the organization level for the quality groups. So defining the standards appropriately, of course, tailoring them to the individual needs, measuring the process. Okay, so measuring the effectiveness of the process and collecting process improvement suggestions from various inputs on process improvement from various groups, and we'll see what sort of inputs, from where we can get inputs for process improvement. So process improvement follows classic PDCA cycle, the plan, do, check, act cycle. And so we plan for the change, we then define goals, do it, see whether that change is adhering to that goal, or that what we wanted to achieve is what we are indeed achieving, and finally roll it out to the entire organization. So here we see the inputs that we can get from various sources for process improvement. It can come from the SQA reports, it can come from the audit reports, it can come from suggestions from the employees, from any business imperative, some competition, from best practices, benchmarking exercises, from individual project requirements, the customer has necessitated some changes. So it could be anything that could necessitate or that could trigger a process change. The way a process change is done, so this is the quality improvement part of the quality management activities, right? We've seen quality planning, we've seen some of quality assurance, we will see quality control, that's testing in the subsequent phases. This is the quality improvement part of the quality management entity. We start with a cost benefit analysis. So obviously anything that we change has, the benefits have to outweigh the cost. So a proper cost benefit analysis is done. Then you set goals for this new process. Okay, so how will things change and how will you determine the effectiveness of this new process? You conduct a pilot, so it's only in one project or one department or one location that you try out this new process. You see whether the results of this process indeed meet the goals that you had set for yourself. Once that is done, then you can disseminate the whole process throughout the rest of the organization, which means of course updating the process documents, training people, and changing the SQA checklist, because now the SQA has to talk about this new process as well when they interact with the project teams. We will talk about the metrics program and the measurement activities in the next unit, but basically when we decide on the software process measures, we have to answer the questions of what we are measuring, why we are measuring, how are we going to do it, who is going to do it, and where and when that activity will take place. Because measures are important, because as they say, you cannot really improve anything that you cannot measure. You have a measure, you have a before measure, and then you have an after measure, right? We are trying to lose weight. What is our weight before we start the diet and our exercise regime, and what is our weight after that? We are trying to build a corpus to buy a house. So what is money that we have available and what do we need to save to go and buy that house? So you have to measure, which means you identify the measures, you collect the measures, collate them, so they all have to be collated, analyze them, consolidate them, and then isolate problem areas and do causal analysis. This in brief is the metrics program, and as I said, in the next unit we will look at it in detail. The SQA is also involved in the defect prevention process. In defect prevention, what happens is that you first of all classify all the different defects that have been collected, that have been collated, identify the ones which are occurring frequently or which are significant errors. So you prioritize using some criteria, do a root cause analysis, and that's why I will be discussing some of the tools to do root cause analysis, and finally decide on a prevention action, specifying a goal. So my defect density today is X, I want to go to a defect density of Y with these defect prevention activities. So that goal has to be set for us to know how we are traveling, whether we are traveling in the right direction or not. And finally, of course, we need to monitor this process, make changes to the goals if necessary, make changes to the process of defect prevention if necessary. Defects data are collected through, again, various forums. One is, of course, the project end reports that are there. Then the metrics analysis, the ongoing project metric analysis that happens and that are reported by the projects on a regular basis. Any audits or assessments done, and any other organization forums that could be there. Let's look at some of the tools that we use for causal analysis. First one, very well known one, is the flow chart. Everybody is familiar with the flow chart. This is used basically to analyze a process and to identify areas of improvement. It is a very powerful tool which will help us identify issues in the workflow and therefore areas of improvement. The cause and effect diagram, or the fishbone diagram, also called the Ishikawa diagram, it's the classic and most common tool for causal analysis, for root cause analysis, and is used basically when we want to identify possible causes for a problem, especially when a collective thinking is failing at a higher level, that time we go on in detail into the problem one by one and find out what the root cause was. Another tool that is used not for analysis but for data gathering is the check sheet. It's those 4 vertical lines and then one horizontal slanting line which crosses it to groups of 5 occurrences. So it's used when data is, can be observed and is collected repeatedly by the same person or at the same location. And when collecting data on the frequency or pattern of events, we can use this tool. So problems, defects, defect location, defect causes, all these could be parameters for which we could use the check sheet. The control chart is another tool. We will look at the control chart in detail, how to prepare a control chart, how to read a control chart, what are the different parameters of the control chart. But basically it is used when you need to control an ongoing process by finding and correcting problems as they occur. So when we want to predict the expected range of the outcomes from a process, then we use a control chart. One of the important parameters that is communicated by control chart is the stability of the process. How stable is the process? We can also use the control chart to analyze patterns or trend analysis of the process from special causes. So basically there are special causes and common causes in a process, and a control chart helps us to identify them. Common causes are inherent in the process and we usually don't do anything to address them, but special causes are definitely something that are non-routine and need to be addressed. Control charts are also used when you are determining whether the quality improvement project should aim to prevent specific problems or make fundamental changes to the process. So again, it is a function of the common causes and the special causes. Another tool which we've all used in our schools, colleges is the histogram. Histogram, of course, when the data is numerical, helps us to get a lot of information. You can see the shape of the data's distribution, especially when determining whether output of the process is distributed normally or not. Again, the significance of normal distribution is something that I will discuss when we talk about the metrics program. The histogram is also used to see whether it is, the process is meeting the customer's requirements, or when we are assessing what the output from a supplier's process looks like, we can use the histogram. Another application of the histogram is to see the process change that has occurred from one time period to another, or to determine whether the outputs of 2 or more processes are different from each other, so we can compare the 2 histograms. And a histogram is a tool or is a diagram that can be used very effectively to communicate and distribute data quickly and easily, because most people understand. The next tool that we will talk about is the Pareto chart. We did talk about the Pareto concept in Unit 1, and the Pareto chart is basically a chart where it's a histogram where the data is plotted in the descending order, and then you can actually see that 80% of the issues or 20% of the issues, as can be seen from this figure, if we address 20% of the issues, then 80% of our problems are taken care of. So the Pareto chart is used when analyzing data about the frequency of problems or causes in a process. When there are many problems or causes and we want to focus on the most significant ones, so the ones which will give us the maximum productivity. They are also used when analyzing broad causes, and then we look at specific components. So we can break one cause into specific components and then look at the contribution of these components into the broader cause. And again, it's an effective way of communicating data to the others because it's easy to read. The next tool is that of a scatter diagram. The scatter diagram is basically a diagram where you determine the relationship between 2 variables. There's the independent variable which is on the horizontal axis and the dependent variable which is on the vertical axis, the y-axis. And for each point you plot, you look at the pattern that the points show. So the pattern of the points basically gives us the relationship, and you find out whether the variables are correlated or not by using the correlation coefficient and doing regression analysis. So when you have paired numerical data, you can use the scatter diagram, and when the dependent variable has multiple variables for each of the independent variable, of course this diagram is very effective. The scatter diagrams helps us to determine whether two variables are related, such that if we are trying to identify root cause of problems, for example, or after brainstorming or using a fishbone diagram to determine objectively whether a particular cause and effect are related. Scatter diagrams can also be used when determining whether two effects that appear to be related both occur with the same cause, or when testing for autocorrelation before constructing a control chart. So as you can see, there are various ways in which scatter diagram can give us information. The first diagram on the second row obviously tells us that there is no correlation between these two parameters, while the others indicate that there is a correlation. The next tool is stratification. This is a tool that is used before we collect the data. When data comes from several sources or from several inputs, such as different shifts or different days of the week, different suppliers or different project groups. So data analysis may require separating these different sources or conditions, and stratification helps us to do that. These were the basic quality tools that are used. Today there are also some advanced tools that are used, and we'll just go through some of them. The affinity diagram. So when we want to prepare an affinity diagram, we record each idea and look for ideas that are related in some way or the other. So we group those ideas together and give that group a name. There could be some stray ideas which are not in any group, and it's okay to have them. There also could be some ideas that belong to two different groups, and if they do, then they find mention in both the groups. After this grouping is done, then the participants will discuss any surprising patterns, any special reasons, or any controversial topics that come up. And when you have many facts or ideas and there's a chaos, so you need to first group them as per their affinity, as per their commonality. The affinity diagram is used when issues are very complex and very large, difficult to grasp, and when group consensus is necessary. So by grouping them, what happens is that it's easy to get that group consensus. There's also the relationship diagram. Again, it basically shows the relationship between the various issues, and we use it when trying to understand links between ideas or the cause and effect relationships, such as when trying to identify an area of improvement, what is the greatest impact? So the cause and effect is easily seen. When there's a complex issue and you're analyzing the causes, you can use a relationship diagram. You can use it when a complex solution is being implemented, or after you have done the affinity diagram, then you can use this diagram to establish the cause and effect relationship, so that you completely explore all the issues of the topic being discussed. The T diagram is very much similar to the cause and effect diagram or the fishbone diagram. Instead of having fish bones here, the tree branches out basically. So again, this is used when the issue is known or the issue is being addressed in broad generally, and then you want to move to specific details of the issue. You can use a tree diagram. When you want to analyze a process in detail, so it basically gives you details just like the fishbone diagram does, again to get the root cause of the problem, and when evaluating several implementation issues for potential solutions. So tree diagram can be used for that. There are various matrix diagrams to be able to see data and get information from the data. Some of them are here for you to see. This is the L-shaped matrix diagram. So there are two parameters, and data on those two parameters are being depicted. In a T-shaped matrix, there are three parameters. So you can read table in, there are two sections, and in each section two parameters are being assessed. One parameter is common for the other two. This is a Y-shaped matrix diagram, again which has three parameters but a little different depiction. The C-shaped, which basically gives a more 3D effect to it. The X-shaped matrix, which has four parameters. Okay, so and in each quadrant the relationship between two of the parameters are described. The roof-shaped matrix is a matrix used to depict the relationship of a parameter on itself. These 5 parameters here and how do they affect each other and itself is depicted in the roof-shaped matrix. It's an arrow diagram which you can use. This uses the critical path method. So it's basically a diagram, the network of the tasks, and flow is from left to right, and the concurrent tasks are vertically aligned. Between each 2 tasks, you draw a circle, which is the event, and the event marks the beginning or the end of the task. So the events are nodes for the separate tasks. And then using the critical path method, the CPM, you find out the critical path, the latest start, early start, latest finish, early finish, calculate slack times. We use the arrow diagram when scheduling and monitoring tasks with a complex project or processes with interrelated tasks and resources. Also, when you know the steps of the project and their sequence and how long each task will take, we can use this arrow diagram. We can also use the arrow diagram when the schedule is critical, so the critical path is important and there are serious consequences for not completing the work on time, or significant advantage if you complete the work early. Sometimes there are penalties for submitting late and some freebies or some incentives given for completing early. Process decision program chart. So you have a tree diagram or a very high level diagram which shows the objective, and the second level which shows the main activities. Then the third level of tasks which are used or which are necessary to accomplish the main activities in the second level. For each of the tasks on the third level, you brainstorm what could go wrong. Again, it's a adaptation of the causal analysis. You review all the potential problems and eliminate that those are improbable or have very insignificant consequences. Then you show the problems in the fourth levels. So for each of these potential problems, then you can brainstorm and make changes to the plan or find out some preventive measures, some corrective action for these measures, and show these countermeasures as the fifth level, which are these cloud type boxes. And to determine how practical each measure is, you use criteria such as cost, time required, ease of implementation, effectiveness, etc. So you use these process decision program charts before implementing a plan, especially when the plan is very large and complex, or when the plan must be completed on schedule. There is no other go, you have to do that, and when the price of failure is very high. So these are some of the modern age quality tools that are used. We talked about cohesion and coupling. Just to quickly and formally tell you about cohesion and coupling. So something is highly cohesive if it has a clear boundary and all of it is contained in that one place. So for example, a ball, right? A ball is very cohesive. Everything that makes up the ball is in that little round circle or the little round orb. The internet, for example, is not cohesive. It is hard to define and it's all over the place. There are too many things that are happening. So when looking at the software, we consider a class or a module to be highly cohesive if it has a clear responsibility and all of the implementation of the responsibility is close or done in one place. Taking an example, if we put all the logic to write to a database in one class or in one module, instead of letting every part of our application that needs to write to the database to implement that logic in our class. A good example in software would be putting all of the logic to write to a database in one class or in one module, instead of letting every part of our application that needs to write to the database implement that logic in its own class. So instead of writing it again and again, that one function will be in one class. Cohesion is simply the quality of a thing being stuck together well. It's cohesive. So we consider cohesion to be a good thing because it makes software easier to understand. It reduces effects of change of one part of the system on the rest of the system, and it helps in reuse of the different. So as we talked about writing to the database, every time there is writing to the database, you just use that class. Coupling. Let's see what is decoupling. Decoupling is the quality of a thing not relying on others or not relying on other things. So we would say that something is decoupled if it does not depend on anything but itself. Something could be highly coupled if it has many dependencies, and this is not what we want in a software. So consider an iPod, for example. It is highly decoupled, right? It is self-contained piece of hardware and it doesn't have dependency on anything. So decoupling is what we need to achieve. Low coupling is what we need to achieve in our software. So let's see how much we have understood of Unit 2. There's an X-shaped matrix that you can see now. So according to this X-shaped matrix A, the Alabama plant has a small volume of model B. B, Zig Corp has a small volume of model C. C, all of the above, both are true, or D, none of the above. So if you see this X-shaped matrix, the top right quadrant gives the relationship between the plants and the model. So if you see the intersection of the Alabama plant and model B, you see that cell is empty. So actually there is no relationship between these two parameters. Let's go to B. B is Zig Corp, the corporation, and the model C, that is the lower right quadrant. So again, if you see the intersection of Zig Corp and model C, then there is nothing in that quadrant. So there is no, again, relationship between Zig Corp and model C. So the answer is D, none of the above. Both are false. Here there is a Y-shaped matrix, and in this matrix you have 4 options. First, that inventory levels have a primary relationship with purchasing, and B, on-time delivery has a secondary relationship with purchasing. C, all of the above, or D, none of the above. Now you have on right in front first phase, vertically you have the inventory levels, etc. You have purchasing in the different departments on the right roof, and you have on-time delivery, etc. on the left roof. So for A, you look at the right hand square where you see that the intersection of the inventory level and purchasing actually has a secondary relationship. It's not a primary relationship. And if you see on-time delivery with purchase, which is the top of the roof, then again you see that there is actually in that intersection of on-time delivery with purchase, there is no relationship at all. So both are false, and therefore the answer here is D, none of the above. Here there is flow chart, and according to this diagram you have to tell whether, according to the flow chart, if the idea is helpful, the rework needs to be done, true or false. If you see the flow chart, the decision is the diamond box. It says idea is useful, yes, no, and if it is yes, then after a series of activities rework is done. So this statement is a true statement. If the idea is useful, then rework has to be done. As per the fishbone diagram, root cause regarding people is geography, true or false. If you see, the geography parameter is a root cause for premises, the title of premises. So it is not a root cause for regarding people, and for this statement is false. As per the diagram, is the root cause regarding people training, is it true or false? If you see under people, there is training, and this is a true statement. As per the diagram, is the root cause regarding people resistance, is resistance root cause for people, true or false? Again, if you see under people, the root cause, there is one of the root cause is one of the fish bones is resistance, and therefore it is a true statement. This is a check sheet table, and this table shows A, how many wrong numbers were received on 6 days of the week, B, how many telephone interruptions were because of the boss, C, the total number of telephone interruptions in a month, or D, none of the above. So the table does not show how many wrong numbers were received really, and it definitely does not show for 6 days of the week. So A is not correct. It shows telephone interruptions, and it does show the interruptions that were because of the boss. So B is definitely right. Let's check for C. Does it show total number of telephone interruptions in the month? No, it just shows for the 5 days of the week. So C is false. So the answer here is B. It shows how many telephone interruptions were because of the boss. What was the total number of telephone interruptions in the week? Was it 49, 3 or 19, or none of them? So if you see the total number of interruptions here, it clearly says it's 49 on the last row, last column, and so the answer is A, 49. What was the total number of causes for telephone interruptions in the week? Were there 49 causes, 3 causes, 13 causes, or none of the above? Well, as you can see, there were 3 causes, the wrong number, information request, and boss. So the answer is B, 3. We talked about rapid application development methodology in Unit 1. So one of the main developers of this methodology was it Albert Einstein A, B, Michael Faraday, C, James Martin, or D, none of the above? I think from your memory you should get that we did not mention anything about Albert Einstein or Michael Faraday, whether they have done something for the software processes or not. We did talk about James Martin, and the answer is C, James Martin. We saw the PDCA cycle. What does PDCA stand for? Does it stand for A, perform, document, control, and assure? Does it stand for plan, do, check, and act? Or does it stand for perform, document, check, and act? Or is it none of the above? Well, it does stand for plan, do, check, and act. It's there in the diagram that we had discussed earlier. So the answer to this question is B. PDCA stands for plan, do, check, and act. The Pareto principle is also called the 80-20 rule, the 70-30 rule, the 60-40 rule, or none of the above. Well, we did talk about the Pareto principle in Unit 1, where we said that 80% of the tasks can be completed in 20% of the disposable time, and therefore the Pareto rule is also called the 80-20 rule. So the answer here is A, 80-20. A set of true or falses to end this unit. Process improvement initiatives can be triggered by a management decision, true or false. Specifically, we did not talk about it, but we did say that business imperatives could be a trigger for process improvement, and that would be a management decision. So the answer to this is that it's true. Process improvements can be initiated by a management decision. The defined QMS should be tailored to meet the project's specific requirements. Yes, it's the QMS is not etched in gold. There should be tailoring guidelines available which help each project to tailor the processes as per their own requirements. So the answer is true. The QMS should have tailoring guidelines for project requirements. Finally, the SQA is responsible for reviewing the project plan but not the configuration management plan. Well, the SQA is responsible for reviewing all the plans, not only the project plan, the configuration management plan, as I said, the communication plan, the risk plan, the verification, validation plan, which is part of the SQA plan. So because it's responsible for all the plans, this statement is false, because the SQA is responsible for the configuration management plan. Thank you.